Hey guys, this next unit what we're going to be doing is talking about some statistics, probability statistics, things like that. So it's a little bit of a take away from pure algebra that we've been doing thus far this year. So really what we're kind of moving in towards is getting away from pure algebra 2 and moving more towards next year. That next year may be taking you to, in this case, maybe AP statistics, or we may be working towards taking pre-calculus and calculus. So our unit after this one is going to be more calculus driven, pre-calculus driven. This unit is more focused on just pure statistics. So when we start talking about statistics, one of the first things we're going to do is really just talk about probability. And with probability, and I can probably just kind of put it off to the side here. So if you're doing just standard probability, that's going to equal desired outcomes over total outcomes. Now, the thing I want to focus on right now is going to be that total outcome. In order to get the total outcome, you have to be able to figure out, based off a scenario, how many possibilities there are in total. And to do that, we want to use what's called the fundamental counting principle. And it works just like this. So again, your fundamental counting principle says if decision M can be made, in this case, M ways, and decision N can be made N ways, then the two decisions together, combined, can be made a total of M times N ways. So what you're going to do is you're going to take your possibilities, you're just going to multiply them together. I have, in the notes that you'll see here, there are 4 examples. Example number 1 states, this is where I'm going to use this fundamental counting principle. I'm not really going to go into probability quite yet, but we're going to be focusing in on this piece. Again, probability doesn't work if I don't know how many total outcomes there are. So we're going to focus on that for right now. So number 1 says we got an ice cream shop. It offers a choice of 3 cone sizes. So that's one option. 15 flavors, that's a second option, and 8 toppings. So we actually have 3 options here. So we can really expand on this fundamental counting principle on this. We have 3 options. It's the same as if we had 2. So in this case, we're saying how many cones are possible if you can only choose 1 flavor and 1 topping. So I want to kind of take all these options and combine them to figure out how many complete options there are. It's very straightforward, very basic. What we're going to do is we're going to take our 3 possibilities and we're going to multiply these possibilities together. The first one is I think of it as every decision you make. The first decision you make is how big do you want this cone to be. So I'm going to go with size first. The second is going to be the flavors. So I'm going to pick a flavor. And the third option here is going to be our toppings. So when you go to pick a size, there are 3 sizes to choose from. When you go to pick a flavor, we have 15 flavors to choose from. And when you go to pick a topping, we have 8 toppings. So all we're going to do to figure out how many possibilities there are in total is we're going to multiply those together. So 3 times 15 times 8 is going to be 360 total possibilities. So that is going to be number 1. And again, all we're doing is multiplying those things together. Next up, we have number 2, Virginia license plates consist of 3 letters followed by 4 digits. So you have 6 total things that we have. And again, we have 3 letters and 4 digits. So how many different license plates are possible? So again, when I'm picking a license plate, I have 1, 2, 3, 4, 5, 6 things that we're going to put in here. So that means I have 6 numbers I need to multiply. These first 3 are going to be letters. So I start with letters. And then I'm going to go with 3 numbers. Now, the thing is with this, that it's a little different from some other things that you may do when you're doing total possible outcomes using this fundamental counting principle, is that the concept here of things being able to repeat. Right now, letters, I can have AAA or BBB. So you have 26 total letters, so that would be obviously 26 options for that first number. But we can have that same letter again. So we're going to have 26 again and 26 again. So next up, we have three numbers, and now we're moving into another type of number that we're going to put in here. And those numbers that we're going to have go from actually 0 all the way to 9. So 1 to 9 is going to be 9, plus 0 is actually going to be 10 digits that we could possibly use. So we're going to have 10 times 10 times 10. So this just simplifies. You're going to write it out. This would be 26 to the third times 10 to the third. And you multiply that out, it's going to be kind of a big number. It's 175 million, not that many, 760,000. So I'm being sarcastic. That's a lot. So that's going to be your total possible combinations for your license plates. So if you think about it, that's how many you can have before you actually have to start repeating a little bit. Luckily, we don't have that many people in one state, or that would be a problem. So moving on, number 3. So with this one, we're going to have, Nick's science test has a section with 12 true or false questions. So how many different ways can Nick answer these questions? So we have 12 questions. Now this might seem a little long. You don't have to do this every time. But we have 12 questions. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So again, you don't have to actually write this out every time. But again, there are 12 questions. And you want to go through each question and say, well, how many options are there for each question? Well, it's true or false. So that would be 2 options for each. I mean, if you were kind of guessing, that's really what we get. So if you want to simplify that a little bit, it's just going to be 2 to the 12th power. If you kind of multiply that out, you're going to get 4,096. And again, the question here is just stating how many different ways can you answer these questions. So we're talking about like all trues and then one false, and then like true, false, true, 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 or you can go true, false, false, true. I mean, if you think about all the different scenarios, there's quite a few. Actually 4,096 of them. And then number 4, last one for the fundamental counting principle, we got to enter their home. The Clayton family enters a 4-digit code. So how many codes are possible? So we're going to enter a 4-digit code. So in this case, you enter that 4-digit code. Same thing as we had over here when we had our digits, is there are actually 10 digits. So we're going to have a digit, a digit, a digit, and a digit. So in this case, we're just going to get 10 to the 4th power. And again, that's just going to give you 10,000 different options. So anyway, that's the fundamental counting principle, and we kind of move on here. You'll see the next thing we're going to talk about is factorials.